In this lesson, we're going to continue working with those negative exponents, but we're going to do it in some more complicated expressions. So it's going to be a little more simplifying to do here. If we look at this, we see that we can move this x to the negative fourth to the bottom. Let me see how they're going to do that. Yeah, we could do this instead. Yeah, both would be true, but I guess what they're doing here is a smarter way to do it. So we know that if we multiply two with the same base, so they have exponents but they have the same base, we can just add them up. Well, that's the smarter way to do it. What I was going to do is going to get you there, but it's going to take longer. So this is the better way. We can just add those and we would get x to the second. Okay, so we do that again. We've got the same base here, so we can add these. And negative 6 plus 4 would get me to the negative second, and then negative 2 can move down to the bottom because of positive 2. Okay, so one more of these. So I can add negative 5 and negative 3 makes negative 8, but let's not leave it there. Let's move it to the bottom, and we get this. Okay, so more of the same here. We're going to add these negative exponents. I won't show this every time, but I'll do it while we're getting used to it here. I can add those, so I get x to the fourth. Now here, if I'm adding negative 7 plus 2, I'd get y to the negative fifth. Now, some people, if you have trouble with the negatives, I don't blame you. It happens a lot. I have a lot of students struggle with that. So make sure you're thinking of it. I would think of it like money. Negative 7. You owe me 7, but you have 2 more. You still owe me 5. We'll revisit our earlier videos in chapter 1. Okay, so this one for C here, I'm going to add negative 4 and negative 5. I'm adding those, okay? Now this is negative 4. You owe me 5 more, so you owe me 9. So that's 1 over z to the ninth without the negative exponent. Okay, I'm going to just add them this time here without writing it out the long way, but this would be a to the fifth if I add these. This would be b to the negative fourth, but we'd want to move that to the bottom and make it 1 over b to the fourth. And then this, if you added this up, you owe me 8, you owe me 7 more. So you owe me 15. You move that to the bottom. All right, now not much changes here. We've seen this kind of thing. This is like multiplying two monomials together. The m's can go together and the n's can go together. So we're just going to, well, let me just do it. So I'm just going to be able to put the m's together. Now I can add them like I did before. So I have m to the fourth. If I'm adding negative 5, I get m to the negative 1. Now n to the negative 3, so you owe me 3 and you're adding minus 2, so you owe me 2 more. You owe me 5. Now we don't want negative exponents, so we can move them both to the bottom. But you can't just leave the top empty. So if they both left and they're both gone, we need a 1 up there. Okay, same thing. We're going to be able to put the p's together, and that's p to the negative third when I add them. And q, so you owe me 2, you owe me 1 more, to the negative third. Now I can't leave, I'm going to move them to the bottom, but you can't just leave the top empty. So we put a 1 up there. Okay, same thing again. I'm adding just the r's. I get r to the negative second. Now I'm adding the s's. We're going to move those to the bottom, but we need a 1 on the top. All right, same exact thing, except now we also have some numbers to deal with. So all of this is being multiplied. So the numbers will get multiplied and make negative 10. The x's will go together. Negative 6 plus 5 gets me negative 1 x's. Y to the eighth plus negative 3. I'm going to get y to the fifth. So I'm going to move the x, the 1x, to get rid of his negative exponent, and the y's will stay up top. Okay, numbers multiply, get negative 12. U to the negative fifth, u to the fourth, that's going to be u to the negative 1. And so at v to the seventh, I'm going to add the two exponents there, I get v to the fifth. Now, let's make this negative 12 v to the fifth, and the u is going to move down below. Okay, so numbers multiply here. I've got negative 6 and negative 5, that's going to be positive 30. If I add c to the negative 6 and add negative 2, I'm going to get c to the negative 8. And d, when I add those, I get to the third. So The c's will then move down below. Okay, this is a power to a power. I don't think, yeah, I don't know that I would do it the way they're doing here. I think I would probably move it down below first. So remember how we get rid, yeah, I think this is the better way to go. What they're showing is true. They're saying that if you have a -2 as an exponent, you give it to both. But I'm not a big fan of that 6 to the -2nd. You could do that. Let's try this where I'm going to move all of this down below and make it to the positive second power. Now, the square goes to everyone inside. So 6 to the second is 36. K to the third to another power, you multiply those and get k to the sixth. Okay, so I'm going to, again, the way they were doing it, it's just another road to get there. It's going to work, but I'm going to make this all on the bottom. So I'm going to put it below because that whole thing is to the -2nd. I'm going to put it all down there. Now, I'm going to share that square with everything inside. So I've got 1 over -4 squared would be 16. X to the 4th to the 2nd would be x to the 8th. Okay, again, I'm going to move it all down to the bottom. Now, I'm going to give the 4th power to everyone inside. That's going to get 2 to the 4th is going to be 16. B to the 3rd to the 4th power is going to be b to the 12th. Okay, I'm going to give in on their method on this one. So I'm going to just share these to everyone inside. So I'm going to make this 5 to the 2nd and -x to the 3rd all squared. So remember, we could share that exponent. Now this is going to be 25, and this is going to be x to the -6, a power to a power. Now once I get here, I'm now going to move that x to the 6th to the bottom to make it a positive exponent. Okay, giving that exponent to both of them. 8 to the 2nd is 64. I've got a, so power to power, a to the -8th. Now let's get rid of the negative and move that down, and I get this. Okay, once again, 2, we're giving that exponent to both of them. 2 to the 3rd is 8. A power to power, well, I guess I didn't, hold on. C to the -12th. Now, move the c down below. Okay, now this one's interesting. Let's see if they did. Yeah, they did the shortcut. This is true. Okay, let me show you what they're doing and then show you how I would do it. So we know the shortcut is that if you've got the same base on the top and the bottom, you can subtract them. And this is true. So 5 minus a -4. Now the two negatives will add together to get you a +9. Now that's clever, and that is a very good trick to understand. But what I think I would have done here is moved those negative r's up to the top to make them positive r's. And then we know how to do this. We just add them up and we get r to the 9th. Okay, 2 roads with a shortcut. It does work, and it's good to understand that. But I think just bringing them up top is a little easier. So you could do x to the 8th minus -3, which is what they were doing. So 2 negatives would make that a positive. You get x to the 11th. But what I would do here is move them to the top. And now 8 there, 3 there, I have x to the 11th. So pick whatever you like there on that. I'm going to keep showing it my way. But the other way is fine too. So move it up, y to the 14th. All right, we have one more of these, and I think they can get pretty crazy. So I'm assuming that we're going to have some really complicated one of these in the next video. So just all we're seeing here is negative, lots of different negative exponents. They become positives when they cross the line.